So दोस्तों, in this series of dynamic programming, today we are going to solve subset sum problem. But before that, let's see what are the questions which are related to 0-1 knapsack. So as I told you, there is going to be a template question, so which is our 0-1 knapsack, and these are the similar questions to 0-1 knapsack. So as you can see, today we are going to solve subset sum problem. And these are like the other different questions that we are going to solve, like जैसे से आगे बढ़ेंगे करते जाएंगे. But थोड़ा सा यहाँ पे एक point बोलना चाहूँगा. The longest increasing subsequence is a template question in itself, but there is a way to solve it through 0-1 knapsack. So in this class we are going to see how to solve using 0-1 knapsack method. But when we are going to solve longest increasing subsequence as a template question, then we are going to use a different approach. Okay, so without wasting time, let's start with our subset sum problem. अच्छा, कभी भी प्रॉब्लम को स्टार्ट करने का एक सबसे बढ़िया तरीका होता है कि कुछ एप्लीकेशन पढ़ लो उसके बारे में. तो that makes very things very easy for us. So if you ask me what are the application of subset sum problem, then it is used in complexity theory and cryptography. अच्छा, क्रिप्टोग्राफी का जब भी नाम आता है ना, मेरे को द इमिटेशन गेम याद आ जाती है. I mean, जो मस्त एलन ट्यूरिंग ने जो बनाई थी, वो जो डेडिकेशन के साथ that he was doing, encryption and decryption World War के टाइम पे, it's really amazing. So that encryption and decryption of the messages that Alan Turing was doing is basically a cryptography. चलो थोड़ा एप्लीकेशन पता पड़ गया तो एक बार प्रॉब्लम स्टेटमेंट भी आगे पढ़ ही लेते हैं. So given an integer array A of size n, you're also given an integer B. You need to find whether there exists a subset in A whose sum equal B. अच्छा, बहुत ही straightforward question है. So let's take an example. The question says you're given an integer array A. Okay, so it has some n elements. So from 1 to n elements, and you're also given an integer B. So let's say you have 1, 2, 1, 3. Okay, and you need to find the sum 5. So it says that you need to check in A whether there exists a subset whose sum equal 5. 5 के equal है? हाँ, definitely है. ये देखो, 2 plus 3 gives you 5. Yes, 1 plus 1 plus 3. This also gives you answer as 5. So right now you just have to tell whether there exists a subset or not. ठीक है? बहुत simple. आगे बढ़ते हैं. Okay, now when we start solving a dynamic programming question, the very first thing is to convert the statement of the question into a selection diagram or a recursion diagram. So 0-1 knapsack में समझाया है, फिर भी एक बार बता देता हूँ. सबसे पहले वो कंडीशन फाइंड करो जिससे तुम्हारा प्रॉब्लम स्टेटमेंट सॉल्व होगा. So let's say if we have array A and right now we are on this element. So we are starting from I equal to n and we'll go all the way up to 1. The first element. ठीक है? So the very first condition is let denote the value of this particular element by s of I. अच्छा. So if this s of I is greater than the sum that you want to find. So let's say you want to find the sum s. ठीक है? जो b था अपना. So you want to find the sum s. And if the value of si is greater than the sum that you are trying to find, then can you include that into your answer? Obviously not. सीधे साधा बोलूँ तो तुम्हें find करना है 5 and the value is 10. Can you include that in your answer? Obviously not. So the very first condition is basically your s of I should be less than equal to the sum that you want to find. और अगर ये false हो गया, if this is false, then definitely you are not going to include. So not include, ni for not include, you are not going to include that particular element into your answer subset. Now if this condition is true, then what? तो अपन check करेंगे that we will include into our answer subset and then we'll check the rest for the rest of the elements, like whatever the sum that will be remain and the remaining elements. So we'll check if we can get that thing. Are we getting an answer? अगर बढ़िया आ रहा है तो good, नहीं आ रहा है तो we'll do one more thing. We won't include this and we'll check कि अब answer आ रहा है. So if you remember, dynamic programming is all about checking all the feasible solution. ठीक है? तो we will include, so we'll see if we include this particular item. So I denotes include, let's say. So if you get answer from here or not include, ठीक है, तो include not include से जो भी तुम्हें आंसर है उसका कोई भी कंडीशन ट्रू हो, अपन बोल देंगे yes there exists a subset whose sum is equal to s. ठीक है, तो अब ये देख के तुम्हें कुछ याद आ रहा है 01 knapsack का? Well, 01 knapsack में we have drawn exactly the same selection diagram, बस थोड़ा सा minute सा change है. So let's see. So in 01 knapsack, what we had was, instead of w of s of I, we had w of I, and we were checking its weight should be less than the weight of the knapsack bag we had. Now if this condition was false, then we weren't including that item in a bag. Obviously भाई तुम 5 किलो का सामान कैरी कर सकते हो, आइटम का वेट 10 किलो है तो नहीं डाल सकते. अच्छा, and if this condition was true, then you were trying to find the maximum value from the two conditions. If you include this item or if you not include this ith item. So if you see, we have just changed that max with or, the remain everything is same. Your s that we are using in subset sum is basically your w of 01 knapsack. ठीक है, चलो थोड़ा और आगे बढ़ते हैं. Next thing that we have is recurrence relation. अच्छा, recurrence relation क्या होता है? चलो बहुत बार बता दिया, बाकी के पुराने वीडियोस में देखना तुम. तो अपन आगे बढ़ते हैं. Recurrence relation. So we have drawn a recursion diagram and now we are going to convert the diagram into a relation. So I'll write f of, we need to write the variable parameters which are changing. So what are the variable parameters? So one is definitely your I which is changing, as your I will move from n to 1. ठीक है, so I'll write I, and the other thing is changing is basically your sum s. So when you're going to include one item in your subset, now you need to find a smaller value. So for example, initially you were looking for sum 10, and in A you have an element say 2 here. So if you include this in your subset, then you need to find 10 minus 2, 8. So your s will be changing. So for these two state, now we are going to write our selection diagram. So the condition says if s of I is less than equal to s. तो यहाँ पे भी मैं सेम चीज लिख देता हूं. If your a of I, अच्छा a of I क्या? I'll just erase these. Okay, so अगर अपन a of I की बात करें, so if a of I is greater than s, तो डेफिनेटली अपन उसको इंक्लूड नहीं कर सकते. तो क्या करेंगे? कुछ नहीं करेंगे, अपन आगे बढ़ जाएंगे, अपन उस एलिमेंट को देखेंगे भी नहीं, एंड वी स्टिल नीड टू फाइंड s. अच्छा, और देखते हैं फिर क्या. अगर कंडीशन ट्रू है, इफ s of I is less than equal to s, then we may include or we may not include. So जो भी अपने को आंसर देते अपना काम हो जाएगा. So f of, let's say if we are not including, now if it doesn't include it, we'll move to the next element and we have to find the sum s. Or, so instead of writing English or, we'll use our coding or, I'll say. So now what we have to do, we are including that item. Here we haven't included, so it's not included. Now or we are going to include it. So we'll move to the next element definitely, but our sum s will also be decreased by the value of a of I. ठीक है, as simple as this. अब कुछ नहीं करना है, इसको कोड करते हैं अपन. ठीक है, we'll code this recurrence relation. Okay. दोस्तों, अपने को डबल मेहनत करने का शौक नहीं है, So we know that the subset sum is related to 0, 1 knapsack. So we'll directly look into whatever we have coded in our previous video, the recursion function for 0, 1 knapsack, and we'll try to trace the same function in our subset. So, but before that, you should know that any recursive function consists of a base condition, a recurrence relation, or a selection diagram, and then finally we have to return the answer that we are calculating from our recurrence relation or the selection diagram. Okay. So in 0, 1 knapsack, we had I to denote the ith item, W to denote the capacity of knapsack bag, and weight array to denote the weight of the each and every item. Similarly, we have our ith to denote the ith element, B to denote the target sum, and our A to denote what? The value of each and every element. So let's write the base condition. So what can be the base condition? Well, the base condition can be if a target sum is 0. Now, if a target sum is 0, well, if you have any trouble, then you can look into your 0, 1 knapsack. It will remain the same. So here also, when our knapsack bag capacity becomes 0, we were returning 0. So here what it means when the target sum is 0? Well, according to question, if we ask that we have to find a null set, then definitely every set consists a null set. So we'll return true. Now the next condition here was if I is less than 0. Okay, so I'll write if I is less than 0. Now what does that denote? That denotes that your B is not 0. So you want to find some positive integer, but you are running out of element. So that means an answer doesn't exist. So you will return false for that particular set. Okay, now the very next thing, even if you see the subset sum selection diagram, then you know the next condition that we write in selection diagram is to check if the ith value of that particular element, it should be less than equal to B. I mean, it shouldn't be, but if it is, then what we do, we may or may not include that particular element into our answer. So if you see the knapsack, then what we're doing, if the weight of the ith item is less than the weight of knapsack bag, then we may include the item and we may not, and we were finding the max among that. So here we don't need to find the max, we just need to find whether there exists an answer or not. So I'll simply write subset, I'll include the item. Now if I include it, then our sum B will reduce by the value of that element and will move to the next element, or we may not include this element into our answer. So in that case, we still need to find B and we just simply move to the next item. Okay, now the last condition that we need is if this condition is false, if the item is greater than the target sum, then obviously we don't need to include that in a subset, and we'll simply write B minus, no, we won't write B, B will remain the same. We'll simply write B I minus 1, okay, because we are not including that item into our subset or our answer. So our target sum will remain the same. So you can see that how much similar this recursion function is to the 0, 1 knapsack. Okay, let's move ahead. अच्छा, कोडिंग हो गई है, तो अब एक एग्जाम्पल लेके देखते हैं. ठीक है, रिकर्शन ट्री देखेंगे अपन. सो suppose if your A consists of elements 2, 1, 3, 2, 2 and you have to find the sum 6. So right now what is your current sum? So it's basically 6 that you want to find, and you are on which number of element? So it's 1, 2, 3, 4, 5. Okay, so you're on the 5th element. So right now you're on 5th element and you want to find the sum 6. So the two possibility right now, 2 is less than 6. So as we know, we may include or we may not include. So if we include this, then we'll come to f of 4, or I will move one step towards left hand side, and the sum that we need to find if we're including is 6 minus 2, which is 4. So we need to find f44, or if we not include this particular item, then we need to find f of 5. No, अरे भाई I तो decrease होगा ना. You have checked this particular item, sorry, element here, item 01 knapsack में बोलेंगे. So you have checked this particular element 4. Now what sum, if you're not including, then the sum 6 will remain the same. Similarly आगे की तरफ भी देखते हैं. Now next element is again 2, so we may include it. If we include it, then we'll get f of 3 and we need to find the sum now 2, or if we not include it, then we are going to get f of 3 and the sum will remain the same 4. Similarly here we need to find for f of 3, and if we include it, then we'll get f of 3 comma 4, because 6 minus 2 will give you 4. The value of the fourth element is 2. अच्छा चलेगा, यहीं रुक जाते हैं क्योंकि मुझे जो बताना है वो ऑलरेडी आ चुका है. So if you see, then this subset is going to get calculated 2 times. Like redundant calculation होने वाली है. So there are some instances in this problem in which we have to solve the same thing again and again. And in order to avoid it, जब अपन पहली बार कैलकुलेट करेंगे तभी अपन उनको स्टोर कर लेंगे, और इसी को अपन बोलते हैं मेमोराइजेशन. ठीक है. सो लेट्स स्टोर द वैल्यू. अच्छा, इसके अंदर क्या सबसेट सम में द वे वी स्टोर, लाइक फॉर दैट वी नीड टू यूज अ मैप, सो अनऑर्डर्ड मैप. सो लाइक वो एक थोड़ा अलग कंसेप्ट हो जाएगा, तो उसको अपन कोड नहीं करेंगे. बट इफ यू गाइज वांट कोड, तो मैं कमेंट सेक्शन के अंदर लिंक रख दूंगा जहां पे तुम उस कोड को देख सकते हो. ठीक है. तो एक बार के लिए इसको अपन थोड़ा सा आगे बढ़ जाते हैं छोड़ के. तो नेक्स्ट थिंग इज सबसेट सम प्रॉब्लम का डायरेक्टेड असाइक्लिक ग्राफ रिप्रेजेंटेशन. अच्छा गाइज, आई हैव ऑलरेडी एक्सप्लेन डायरेक्टेड असाइक्लिक ग्राफ रिप्रेजेंटेशन ऑफ 01 knapsack, और अब सिमिलरिटी तो तुम्हें मिल ही चुकी है. तुम्हें और बता देता हूं, जो तुम्हारी y एक्सिस थी तो वो सेम रहेगी. इंस्टेड ऑफ आइटम, नाउ यू आर गोइंग टू राइट द एलिमेंट्स. ओके. एंड x एक्सिस में क्या था तुम्हारा 01 knapsack के अंदर, उसमें था तुम्हारा the bag, the capacity of the bag. Now instead the capacity of the bag, what we have here in subset sum, well, we have b. What is b? It's basically the sum that you need to find. ठीक है. Rest everything will remain the same. And मैं तुम्हें encourage करूंगा कि तुम खुद से डायरेक्टेड असाइक्लिक ग्राफ बनाओ और देखो कि वो जो टेबल बन रही है उसके अंदर सबसे पहले अपने को यहां से क्यों स्टार्ट करना होता है. ठीक है. सो डू इट बाय योरसेल्फ, तो कि तुम लोग को लाइक यू नो एक फीलिंग आएगी कि इटरेटिव सॉल्यूशन के अंदर कैसे टेबल फील हो रही है. ठीक है. चलो तो अपन आगे बढ़ेंगे और इसका इटरेटिव सॉल्यूशन करेंगे. ठीक है. ओके दोस्तों, सो नाउ वी आर गोइंग टू कन्वर्ट आवर रिकर्शन फंक्शन इनटू एन इटरेटिव सॉल्यूशन. And you will know that why I always insist telling you that first write an recursion function and then write the iterative solution. Okay, so you guys can take the input in whichever language you are using. I just simply tell you that what the variable denotes. N denotes the n elements, P denotes the target sum that we want to find, An is an array which is going to store the n elements in a zero based indexing way. So A0 denotes the first element, A1 denotes the second element, and our dp of n plus 1 w plus 1 is a two-dimensional dp that we are using, an array, a two-dimensional array to store the values. Okay, so very first thing, if you have drawn the directed acyclic graph of subset, then you know similarly just like the way we were doing in 01 knapsack, like the directed acyclic graph is also same as of 01 knapsack. So we need to iterate over each and every item. So I've written our knapsack code in the previous video. So we go and check all the item. I equal to 0 denotes 0 item all the way up to our n items, and our int j goes from 0 all the way up to w. That is the knapsack bag capacity. So as we know, our item goes from 0 to n, and instead of w, what we have in a subset sum is the target sum that we are finding. So int j equal to 0 and j goes all the way up to b that we want to find, j plus plus. Now what's the next thing that we do? Well, we write the base condition. So what is the base condition? If b equals 0. So that means if b is being denoted by j, so if j equals 0, the that is the case, then dp of ij equals to true. Okay, else if, so let's see the next condition. If I is less than 0, then return false. अच्छा, तो एक चीज बोलूंगा, let's see what that statement means. So in recursion, I less than 0 was denoting that there are no more elements. Remember what I said, no more elements. So here an iterative solution, I equal to 0 is denoting that there are no elements. So I'll write if I equal 0, then dp of ij equals to false. Okay, now we'll write the next condition. So what's the next condition? If ith element value is less than equal to the subset, the sum that we want to find. Okay, so else if a of, so should I write I? Well, if you will look carefully, then in recursion function we were using 0 based indexing, but here we are using 1 based indexing, as I equal to 0 is denoting no elements. So I need to take a value less than what we are taking. So less than equal to, instead of b I'll write j. So a dp of ij equals to, now look at our recursion function. So we may include it in our answer or we may not include it. So I'll do the same. I'll include this element into our answer. So I minus 1 and j minus a of I minus 1, or I may not include dp of I minus 1 j. So if any of the condition is true, then for the answer for this will also be true. Okay, so the final condition that we want to find is dp of ij. In case if that particular element is greater than j, then obviously we cannot include it. So we'll simply write I minus 1 with the same target sum that we want to find, that is our j. That's it guys, it's done. Our answer will be stored in the last bottommost right element. So see out dp of, for n items, if you want to find the sum b, so this is where your answer will be stored. That's it. Now if you want to trace it, you can trace it with 0 1 knapsack, and you can see that the function was almost same. The base condition depends upon the language of the function, and the main part of the function, here we were finding maximum value in 0 1 knapsack, but in subset sum we just want to find whether there exists an answer or not, so we are using or. Okay, the rest everything remains the same. चलो ये भी हो गया. So I hope you have like this video. अगर अच्छा लगा हो तो like करो, कमेंट करो और अपने फ्रेंड्स के साथ शेयर करो इस वीडियो को. नेक्स्ट वीडियो के अंदर अपन थोड़ा बहुत प्रैक्टिस कर लेंगे मेमोराइजेशन, क्योंकि लाइक मेमोराइजेशन इज रियली इंपॉर्टेंट. रिकर्शन और मेमोराइजेशन, लाइक कोई भी प्रॉब्लम स्टेटमेंट गिवन हो उसको सबसे पहले कन्वर्ट करो एक सिलेक्शन डायग्राम में, उसका रिकरेंस रिलेशन लिखो और मेमोराइज करो. ठीक है, तो नेक्स्ट वीडियो के अंदर अपन थोड़ी उसकी प्रैक्टिस कर लेंगे. अभी के लिए इतना ही. जय हिंद दोस्तों. और ये चीज याद रखना कि अपने आने वाले जो वीडियोस हैं वो क्लास 1 के नहीं होंगे, बट बेसिकली एक तरह से प्रैक्टिस वीडियो टाइप होंगे, तो उनको प्रैक्टिस जरूर करना. और ये जो भी पढ़ाया है वो भी खुद से लाइक प्रैक्टिस करते रहना और उनको कोड करना, तभी तुम्हें चीजें क्लियर होगी. ठीक है, तो मिलते हैं नेक्स्ट वीडियो में. बाय दोस्तों.